Given question, find the magnitude and nature of forces in the members U3, U4, L3, L4 and U4, L3 of the loaded truss.
This is the question. Under condition, we have to find out unknown forces in few members but not in all members. Therefore, we are going to use section method. There are some basic rules while using the section method. We can pass this section in maximum 3 members with unknown forces and not more than that. Second condition is we have to choose the section line in such a way that it will separate the entire frame into two parts. Now, if we observe this question, we have to find out unknown forces in the member U3, U4, L3, U4, L3, L4. So, I will draw here the section line in such a way that the section line will cut all these three members and it will separate the entire truss into two parts. So, I will draw here one vertical line and this will known as section 1-1. Now we can use the equilibrium of any one part. So for this question we will choose the equilibrium of this right hand side part. So we have to remove all the left hand side part while using the section method. But first step is to determine the unknown reactions at the support. Now if we observe this truss, then at the point L0 this hinged support is given. That means the whole truss is free to rotate about this hinge. So reaction can be in any direction. So we will resolve this reaction into two components, vertical component and horizontal component. So I will show here vertical component as a VL0 and horizontal component as a HL0. Now second support is given roller support at point L6. So we have to show reaction perpendicular to the surface. So this roller rests on horizontal fixed surface. So we will show vertical reaction at the point L6 and we will say that it is RL6. Now we have to find out these unknown reactions at the support. So how to find out? So we have to consider equilibrium of this whole system. Now when we consider equilibrium of the whole system, then we can say that summation of moment of all the forces about any point is equal to 0. Summation of all vertical forces is equal to 0 and summation of all horizontal forces is equal to 0. Now if we observe this, at this point L0 there are two unknown forces. So if we take the moment of all the forces about point L0, then we can find out this unknown reaction RL6. So we will first take summation of moment of all the forces about point L0 is equal to 0. So this moment of HL0 and VL0 becomes 0 because these two forces acts at point L0. Now how to take the moment of these 200 Newton? So if I move the compass about point L0 in the direction of 200 Newton, that is in the downward direction, then here is the clockwise. So for the clockwise direction we will take plus sign or positive sign. So this positive sign multiplied by this 200 Newton force multiplied by perpendicular distance from L0. So this is the line of action of force, that is in the downward direction, and perpendicular distance is 6. So plus 200 into 6. Next plus 200 into perpendicular distance 6 plus 6 12 plus 150 multiplied by 6 plus 6 plus 6, that is 18. Then next is 100 multiplied by 24 plus 100 multiplied by 30. Now this RL6 is in the opposite direction. So if I take the center as a L0 and I will move the compass in the upward direction, then here is anti-clockwise direction. And for that we have to take negative sign. So we can say that minus RL6 multiplied by perpendicular distance 36 is equal to 0. So RL6 is equal to 325 Newton. And its sign is positive, so for positive sign upward direction, that means this direction is correct. So we will keep as it is. Now we will find out this VL0 and HL0. So we will take second rule, summation of all vertical forces is equal to 0. So for vertical direction use positive sign, for downward direction, for upward direction use positive sign, and for downward direction use negative sign. So we will take plus VL0 plus RL6 minus 200 minus 200 minus 150 minus 100 minus 100 is equal to 0. Now RL6 is known. We will put here the value. So VL0 is equal to 425 Newton. Now we will find out HL0. So summation of all horizontal forces is equal to 0. So there is no any horizontal force in the system. So this HL0 is equal to 0. So there is only VL0 and it is equal to 425 Newton, and it is having positive sign. That means its direction is upward direction. We will consider the equilibrium on the right hand side of this section 1.1. So on left hand side we have to remove all the parts. But the question is we have to find out the unknown forces in the members U3, U4, L3, L4 and U4, L3. So I will complete this left hand side part with these members with the help of red marker. So I will make here the construction with the help of dotted lines. Then here is L3U4 and L3L4. So on this left hand side we have to complete this with the help of dotted line. Now if we observe this U3, U4 as well as L3, U4 are the inclined members. So we have to find out angle of inclination. So how to find out this angle of inclination? So I will take here one horizontal line. So I will draw one horizontal line passing through this joint U4 and I will complete this triangle. Suppose we will give here this X. Then in triangle U3, U4, X we have to find out angle theta1. In triangle U3, U4, X we can say that tan theta1 is equal to U3X divided by U4X. Now what is the value of U3X? So this height is mentioned. L4 to U4 height is given 8 meter and L3 to U3 height is given 9 meter. So this L3X is equal to L4U4. So this remaining height is equal to 1. And this horizontal length U4X is equal to L3L4 and that is equal to 6 meter. So tan inverse of 1 by 6 is equal to 9 degree. Now we will find out inclination of U4L3 with this vertical line. So for that I will mention here angle theta2. So tan of theta2 is equal to this opposite side L3L4 divided by U4L4. So this L3L4 is 6 and U4L4 is 8, that is the height. So tan inverse of 6 by 8 is equal to 36.8 degree. Now we will find out the unknown forces in the members. If we observe from joint U4, there are two members U3, U4 as well as L3, U4, in which we have to find out the unknown forces. but this L3L4 is not passing through this joint U4. So we can take the summation of moment of all the forces about point U4, because we have considered equilibrium on this right hand side part. So we will select here the joint U4 and we will take summation of moment of all the forces about point U4 is equal to 0. So how to show that? So we know that moment, that means force multiplied by perpendicular distance. So here we have to take first this member is FL3L4, that is the unknown force in the member L3L4 is FL3L4. So we will show here the direction of force. So in the member we will show the direction in the outward direction. So we have to consider only this half part. So this member is along this line and I will show the direction. Now this force FL3L4, this force is known as FL3L4 multiplied by the perpendicular distance. So perpendicular distance from U4 is known as 8 meter. So FL3L4, so I will mention here FL3L4 multiplied by perpendicular distance 8. Now if I move the compass about point U4, then it is in the clockwise direction. So if we observe here, if I move the compass about U4 in this direction, then here is the direction. So we have to use positive sign. Now we will move to the next force. So next force is 100 Newton, but it is passing through U4. So we are not going to consider because perpendicular distance is 0. Now next force is 100 Newton. Now this 100 Newton line of action of force, if we observe, perpendicular distance is equal to 6 meter. And if I move the compass about U4 in the direction of 100 Newton, then it is also in clockwise direction. So we will take plus 100 multiplied by 6. Now next is this RL6. Now if I move the compass about U4 in upward direction, then it is in anti-clockwise direction. So we will use negative sign. So minus RL6 into perpendicular distance 6 plus 6, that is 12, is equal to 0. So RL6 is 325 Newton. So when we calculate, we will get FL3L4 is equal to 412.5 Newton. Now this is the positive answer. So for positive answer, nature of force in the member is tension, and we have to show this, that is the tension. Now we will move to the next. So next we will consider the joint L3. So if we observe, from this L3 there are two members passing, that is the member L3L4 as well as member L3U4. And one member U3U4 is not passing, and the question is that we have to find out the unknown force U3U4. Now U3U4 is the inclined force. So we have to resolve this into two components. Now here also we will consider from this U4, direction of this force U4 U3 is in the outward direction. Now I will resolve this force, inclined force, into two components. First is horizontal and second is vertical component. So I will remove this construction. So I will show here horizontal component, and here is vertical component. Now how to write the value of horizontal component? So this is FU4U3, or we can say FU3U4. So it is FU3U4 cos of theta 1, and its value is FU3U4 sin of theta 1. Now we have to take the moment of these two components about point L3. So when we take the summation of moment of all the forces about point L3, then it is equal to 0. So we will consider the first force FU3U4 cos of theta 1. Now if I move the compass about point L3 in the direction of this, then it is in the anti-clockwise direction. So I will show here the direction. So this is the anti-clockwise direction. So we have to use negative sign. So minus Fu3U4 cos of theta 1 multiplied by perpendicular distance. So this is the line of action of force. So this perpendicular distance is equal to 8. So we have to take 8. Now in the same way we have to take the next vertical force Fu3U4 sine of theta 1. So this is the line of action of force. So perpendicular distance is equal to 6. Now if I move the compass in the direction of Fu3U4 about L3, then it is also in anti-clockwise direction. So use negative sign. So we have to take minus Fu3U4 sine of theta 1 multiplied by 6. Now we will move next. Now the next force L3L4, it is passing through L3. Then we have to take this 100. So for 100, if we observe, then if I move the compass about L3, then it is in clockwise direction. So we have to take positive sign. So plus 100 into 6. Then this plus 100 into 12. And then if I move the compass about L3, then this in upward direction, then it is anti-clockwise direction. So minus RL6 multiplied by 18 is equal to 0. So RL6 is 325. So we can put directly value. Now if we observe, we have to find out this unknown force Fu3U4. So we can take the common from first two parameters. So I will underline this. So I will take common term minus Fu3U4 as a common term. So inside the bracket we have to solve this. Cos of theta 1 is cos of theta 1, that is cos of 9 degree multiplied by 8 is 7.9, and sine of theta 1 into 6, that is 0.9. So we have to take this in the bracket. So minus, I have taken the common term, so here inside the bracket plus sign, and I will transfer all the terms to the right hand side. So Fu3U4 is equal to minus 460 Newton. So how we can write this? So this is the compression force. So we have to show that, which is equal to 460 Newton, and with compression, that is the nature is compression because magnitude of force is negative sign. Now we have to find out unknown force in the member U4L3. So we will show its a direction, outward direction from this joint U4, and we will resolve this force into two components because it is the inclined member, vertical component and horizontal component. So here is the vertical and here is the horizontal component. Now how to decide its a value? So it is making angle theta 2 with vertical line. So with vertical component we have to show that it is Fu4L3 cos of theta 2. Fu4L3 cos of theta 2, because it is nearby to angle theta 2, and here Fu4L3 sine of theta 2. So we have to find out this unknown force Fu4L3. So we will consider summation of all horizontal forces is equal to 0. So if we observe this system, then horizontal forces are Fu3U4 cos of theta 1, Fu4L3 sine of theta 2, and L3L4. So this is also horizontal force we have calculated. So all these forces having direction towards left hand side. So for all these forces we have to give minus sign. So minus Fu3U4 cos of theta 1 minus L3U4 sine of theta 2 minus L3L4 is equal to 0. Now we have to put the value. So remember, for any force we have used direction in the outward direction from the joint. So whenever that particular force is having negative magnitude, so we have to use that magnitude with sign, because we have used the same direction for all these members. So here Fu3U4, this force is having negative sign minus 460 Newton. So we have to use as it is, that is minus and instead of FU3U4 minus 460 cos of 9 minus FL3U4 sin of 36.8 minus 412 is equal to 0. So this minus minus will become plus, and when we solve this, then we will get FL3U4 is equal to 70 Newton. So it is with positive magnitude, so nature is tension. For final answer, we will prepare table. So in member U3, U4, magnitude of force 460 Newton, nature is compression. So for compression nature, we have to show arrow towards the joint. So there are two joints, U3 and U4. So we will show arrow which is the direction with towards the joint for U3 as well as U4. So these directions are opposite and magnitude is same. L3, L4. Nature is tension. So for tension we have to show arrow away from the joint. So we will show arrow which is away from the joint L4 as well as for L3. Then next is L3, U4. So for L3, U4 magnitude is 70 Newton, nature is tension. So for tension we have to show arrow away from the joint. So for L3 also we have to show arrow away from joint, and for U4 also we have to show arrow away from joint.